And so really it wasn't that I always knew I wanted to be an electrical engineer. It's that fundamental physical principles and mathematics were appealing to me. And then once I discovered the people that harness those laws to do interesting things and to solve problems, those are electrical engineers. And then I started to realize this is where the action is. This is what I want to be. My name is Jonathan Chisum. I'm an assistant professor in the Department of Electrical Engineering at the University of Notre Dame. My group's research combines traditional electromagnetics design and principles with emerging materials and devices to both solve the current issues in commercial and national defense, as well as to provide completely new functionality and capability in those sectors. Our interests are in wireless communications and in sensing. This includes radar as well as passive sensing. An example of a project where we're dramatically improving the current capabilities for wireless communications is in our gradient index lens antenna technologies. There we've developed what we call high contrast artificial dielectrics to design and fabricate lenses for applications in 5G as well as next generation wireless communications and satellite communications. This technology helps to solve problems in an interference-dominated environment, as well as operates at a very high frequency and can still be deployed on battery-powered or small platforms where power is limited. Another example of a project where we're providing completely new functionality, something that's not currently possible, is in our programmable RF circuits and antennas project. There, we're taking advantage of a material called a phase change material, which is either an insulator or a metal, depending upon some control mechanism, whether it be a field or a temperature. In that project, we've developed a low-loss version of these materials that can be precisely defined so that we can arbitrarily draw the shape of a conductor. Our goal is to bring to bear the capabilities of new materials and new devices to dramatically improve the current performance, whether this is bandwidth, operating frequency, or power efficiency, as well as to introduce completely new functionality. We're at the edge of what the materials can provide for us. And so when we see a new material come out, we can take advantage of that new capability. My graduate courses, I tend to operate them more as a mentorship sort of opportunity. We usually have small classes in high-level graduate classes, and they usually take place in my laboratory. So we'll have a lecture component, and then I'll invite them into my lab, and we'll work side by side together. And I really view that laboratory component of my graduate courses as an extension of my research laboratory into the classroom. And this really helps to bridge the gap between theory and practice.
I think the biggest thing that I have observed in him that speaks highly to his competency is that he has a wide range of knowledge, even in field outside of his core field. And so he's able to interact with lots of people across the department and be able to bridge fields in the department that otherwise would not be able to talk to each other. That has been a major component of his role in the electrical department at Notre Dame. He's also expected his students to acquire a broad understanding of a lot of aspects of the RF field.
The thing I really like about Dr. Chisum is that he has an infinite patience. I can't think of anyone that I would rather work for.
He weighs our opinions, and he knows we're sufficiently far along where we can have insights at things that maybe he won't think of. Ego doesn't come into play with him. He's a good leader. He's got this vision. He doesn't get in your way. It's amazing because he says, this is what we need to do. And he lets you go do it.
So it's electrical engineers that really have made our modern world possible.